Hello, in this video I will explain you the examples of natural selection. Hope this text will make it very clear. So the first, these are 4 examples that you will face most of the times in your syllabus and exam questions. We have these mosquitoes and houseflies, right? The common ones, right? And we will see about the melanic moth, right? And then we have this Escherichia coli, which were it's the penicillin issue, right? And lastly, we will have this the bacteriophage viruses. Now, even this I think is the Escherichia coli, right? In bacteriophage viruses. Okay, so these are the 4 examples you will most of the time face. And now let me just explain you what do they talk about, right? Earlier in England, as you say here, in England there were these plants, right? Maybe I need a drawing. I think so. Okay, there were these plants in England which let me not lose the oops. Okay. Oops. Right now you guys it's full. Yeah. So there are these plants in England, colored moths, they're perfectly camouflaged. So we had these plants which the moth, okay, the moth are grey in color. We know that, right? They're grey in color. They were grey in color, but then after some time, here it says they became dark, right? These days they are dark. And why are they dark? Because this darkness sort of make this darkness, okay, protects them. So they sort of become dark because they become more adapted to the environment. Now, logically, like if you think about it, you may say, oh, okay, so like the parent changes the sun in such a way that they become more adaptive to the environment. Well, that's not the case here. I mean, in the logic of natural selection, that's not at all the case. There is no any genotype change. The genotype do not change the genotype do not change at one instance, okay? It does not change. This only change if there is mutation, and there is only most of the time there are only single changes, like minor changes, okay, which only sometimes cause problems. So this mutation is another case. It's not with the natural selection. Natural selection is something else, right? Okay, it can involve mutation, but then it is some other thing, and maybe the moth example will make it clear to you. So what happened actually in that era was that there were this sorry, let me just remove this so we get space to work. So yeah, there were this gray, right? There were this gray which were camouflaged. So there are these trees, grey color trees because of the industries. Sorry, I think I should draw this grey color. There are these grey color trees because of the industries, right? But then these grey color trees did not remain the same. They became black. So let's say this is 19th, okay, no, let's say this is 20th century. 20th century, this is 19th century, right? So this was the tree in 19th century, this was the tree in 20th century. So over here, there are this gray birds, right? The moth, there are this gray moth, and maybe there are just two black moths, okay? But then this black moth really, because there were four, but then other two must have died because they can be seen easily, right? So they died, they sort of died. But then when the conditions were changing, they're becoming darker. Now the darker one got more protection. So now this dark this one or two which survived, they reproduce, right? So they will have around 4 here. But then this one, since the tree has become darker, the tree has become black now, there is no camouflage for these ones. So these ones are dying now. So only 2 are remaining. Okay? So that's the logic over here. Like the natural selection is selecting for the best adapted species, and the other ones, I mean the one which can take on the selection, it can fight the selection pressure. Okay? It is the survival of the fittest, because only the fittest one, in this case the fittest was the black moth, and in this case the fittest was the gray moth, and that's why there are more gray moth over here, whereas there are less gray moth here, and there are more black moth over here than here. So hopefully that was clear, the natural selection, and that's why we are told, we are explained in this context in our paper. So that was with the Biston Betullaria, the first example. Now the second example is the same, is the mosquitoes, right? Now they say that DDT was used extensively, sometimes by airplanes. You may need an explanation here, very nice explanation. First let us read. So this was a DDT. This DDT is not it's some insecticide, right, to kill mosquitoes and houseflies. So it was used extensively by airplanes over large areas. Initially it killed 99% of mosquitoes population, but at the same time put a lot of pressure on the surviving individuals to mutate. Mutant resistant strains survived DDT application and became the parent of the next generation. Natural selection preserved the resistant populations and eliminated the susceptible ones. Okay, this can be called an artificial selection event, due to which today not only mosquitoes and houseflies but also many insects have become resistant to most of the available insecticides. Now here is the same logic. Maybe I should explain to you so that you don't get caught up in something and maybe get confused. Okay, so we have this mosquito. Let's say there is mosquito A, there is mosquito B, there is mosquito C, D, E. Okay, and sort of this mosquito D has this something to protect it against the penicillin. Okay, so we have this penicillin coming and attacking this, coming and attacking this. Okay, so this is what happens. These all are attacked. Okay, so after some times, what happens is because this can survive. So maybe only 1C survived, A all were dead, and then 1B survived, E were dead, and then D, because they had this camouflage, it survived, and then it reproduced so many, like maybe 3 reproduced. So there are 3 Ds right now. Okay, these are the mosquitoes. So the ones with protection are going on now. There are 3. Now again, as we go on, this they still survive because they have a protection, right? So eventually these two also die. So what we have at final is all these also die, right? Because this one comes and attacks this, comes and attacks this, comes and attacks this, but it can't, it rebounds, right? But then here it attacks, it kills. So eventually we have these ones reproduce again. Okay, so we have this all the final insects who are resistant to the insecticide. Okay, so it was not penicillin here, it was the insecticide. The penicillin issue is for the next one. Hope I didn't confuse you much over there. As you know, right, this sort of explanation was not that clear. So that was clear. That's all with these, and this is the mosquito case. Now the same thing is with the bacteria, Escherichia coli. They're susceptible strains to penicillins repeatedly, so the best get selected and they go on. Then the one that eventually remains, like these D ones, the one which eventually remains are the one which have the sort of a protection against the penicillin, and in this case against the mosquito sprays, right, the DDT. And by mutant resistant strains, what we mean by mutant first is that these are formed by mutation. There was some mutation in the past which created a certain trait which is different from the original one, which sort of have the ability, which sort of produce this shield kind of thing. Okay, and only this one will have shield while others all will not have shield. And that's the case with the Escherichia coli, and the same thing here with the bacteriophage virus. The same kind of mechanisms is used. Hope that was very clear, and the examples are hopefully very clear. Thank you for listening.